In this third video, I'm going to demonstrate how to account for supply-side opportunity cost when we expand our local foods production. In specific, we're going to have to account for taking acres away from some type of production if we're going to introduce a new type of production. Many local foods analysis, especially impact analysis, often focus on the gross gains that might be generated in a region from some type of local foods growth scenario. In most places of the United States, however, nearly all of the productive land is already tilled and producing crops. As a consequence, local foods acres will have to come at the expense of other land uses in those areas. There has to be a shifting of usage from one type to another if we're expanding our local foods production in an area. This exercise will demonstrate that process of offsetting local foods gross gains with the losses that would have been realized from foregoing existing uses of land. In this case, I'm going to use Kane County, Illinois as my demonstration county. Work was done in 2013 with Kane County to come up with a bundle of locally produced fruits and vegetables that would accommodate regional demand, potential regional demand for local foods, with an assumption of consumption that a relatively good fraction of the region's local food needs would be met by county producers. That scenario assumed the region could competitively produce and market a bundle of 24 vegetables and fruits, and they're listed right there. And in a previous video, I showed how we created this local food sector and had 21 jobs per 1,000 acres of baseline production of fruits and vegetables, producing that bundle, and it would have $4.35 million worth of annual sales. The rest of the components of value added are listed in that chart as well. That output value was entered into the in-plan model for Kane County, Illinois. And after the model had processed all of the information, it produced a table of gross economic activity associated with expanding 1,000 acres worth of local vegetables and fruit production in Kane County. And so we found that in Kane County, once everything multiplied through, we would get a total of 46.3 jobs associated with that original producing fruits and vegetables off of 1,000 acres. Nearly $6.82 million worth of total industrial output in the region, $2.1 million worth of labor income, a subset of value added, which was $3.1 million. But these are the gross effects, and it doesn't take into account, though, that 1,000 acres to produce these fruits and vegetables had to come from some other type of cropping in Kane County. To calculate the offsets, we have to figure out exactly what kind of acres we're taking out of production from one type of use into our local foods use. In Kane County, Illinois, the vast majority of land is used for corn and soybean production. So we have these values from agricultural statistics, USDA agricultural statistics. In that year, Kane County produced 92,000 acres of corn and 42,900 acres of soybeans. So I could figure out right away what's the distribution, or what's basically the probability, if I'm expanding my local foods acres, what's the probability that those acres would be corn acres or soybean acres? The next thing we did was we're just simply going to use the information that's in the in-plan model right now. And so we turned to the in-plan model to find out the total output that was recorded in these two sectors for the year that we had the model. And in the year of the model, the corn production sector in that region had $111.9 million worth of output. The soybean producing sector had $30.2 million worth of output. Now combining both government statistics plus the values that we generated from, or we had in our in-plan model, we can then figure out what's the output, the expected output per acre. So for corn production, it was $1,216 per acre. For soybean production, it was $703 per acre. We arrived at that number by simply dividing column D, total output, by column B, the total acres that were in production. And last, we have to come up with the offset values. The offset values are very, very straightforward. They're the output per acre for each of our crops, for corn and soybeans, times column C, the apportioning percentage, 68% and 38%, times 1,000, which is the number of acres that we're taking out of production. And when that was done, we arrived at these foregone output per 1,000 acres of land apportioned to local foods. Now these values, these negative values for corn and for soybean production, are then entered into the M-Plan model. From the basic M-Plan model then, we'll go to analyze, and what we're going to do is set up an activity, and what we need to do is create an activity that offsets our local foods economic estimate. So it's going to be a new activity, and I'm going to name it conventional offset. And in that conventional offset, I'm going to have a new event. My first event, I'm going to start with corn, which is grain farming, number 2, but in this case it's corn. And the offset is going to be a minus $829,248. And we hit enter. And then the next event to be offset was the soybeans. That was sector number 1. And that was a minus $223,704. Now we can run this through the model and get our estimated offsets. And after a bit, our impact or our offset values emerge. So after removing 1,000 acres of conventionally farmed land from Kane County, we have an offset of 13 jobs, output of $1.56 million, labor income of $332,972, and a value-added offset of $695,810. We're simply now going to difference the two, the local foods economic effect minus the offset, to come up with an estimate of our net regional economic gain from this shift. We can now difference the totals from the two input-output runs. By taking our total local foods economic effects, we can now difference the two runs from the M-Plan model. By taking the total local foods economic effects values and subtracting the conventional farming losses, we get net regional gains associated with our local food scenario. Remember, we were adding 1,000 acres worth of production to the regional economy. So our net gains were 33 jobs, $5.25 million worth of output, $2.4 million worth of value added, and $1.73 million worth of labor income. So we've now compiled a reasonably accurate and reasonably honest assessment of net local foods gains. By making sure that we account for the acres required for local foods production, knowing that it has to come from some other use, we've done a much more honest assessment of local foods' potential regional economic gains. There are other opportunity cost considerations as well. We're not going to show them in this video, but that you need to pay attention to them if you are going to do an honest accounting of the net gains associated with local foods production. For example, farmers selling at local farmers markets very well may need to consider, especially under a growth scenario, whether that has an impact on existing retail grocers when you're describing your potential regional economic gains. And for more developed regional food hub systems, we may also want to consider growth consequences that might be offset because of losses to other regional food-related trucking and warehousing activities. The bottom line, though, is when you're doing local foods economic impact evaluations, you need to pay attention to opportunity costs and appropriate offsets to expected gains.